We'll do a simple example of an iDevice with a quadratic IV relationship. Quadratic IV relationships can be found when you use MOSFETs. First, we'll have a current source that the current equals a scaling constant times V squared. In our example, we'll use A as 0.1 amp per V squared. Our input DC voltage will be 2 volts, and our AC output voltage will be 10 millivolts times a sine wave. And this would be the complete circuit. You would add the AC and the DC sources together, go through the R load. This would be V out, which now the current would be given as 0.1 amps per V squared times V out squared. The first thing we need to do is to find the DC response. And what we do is we just short the AC signal, and we're left with this circuit. Then we can just write our equations. Minus 2 volts plus the current times the load resistor plus V out should equal 0. We substitute our I for our current equation, and then rearrange into a V out squared, V out, and then no V out, which is the quadratic equation. A is equal to 100, B is equal to minus 2, and B is equal to 1, and C is equal to minus 2. Here's the quadratic equation, and we have a choice. Is it plus 28.3 or minus 28.3? Well, when you solve it, we get a positive voltage in one case and a negative voltage in another case. Well, it needs to be a positive voltage in this example because the power supply is 2 volts measured with reference to ground. There is no negative voltage power supply in this example. So now we get the full DC response. Our V out is 0.136 volts. And this is our current, 0.01365 amps. Now that we have that DC response, we can find our AC resistance of the current source, which is really 1 over the derivative dI of the current voltage, which in this case is 36.63 ohms, and the derivative of that current equation is shown here. All right? And the AC resistance of 1 kilo ohm is 1 kilo ohm. Now the AC response is really just a voltage divider of the AC current source resistance and the kilo ohm resistor. So our AC input voltage is 10 millivolt sine wave. See those equations? And so we get 0.35 microvolts times our sine wave. So our complete response is our DC voltage plus our AC voltage. And that way we are able to break up a complex problem into a DC and an AC response to get the full response by adding them together.